inside a filter clause. So pretty much something like this, right? Filter and then category matching, something called brewing in beats, blah, blah, blah. But one interesting thing is, because strings, we have two data types. Strings is either text or a keyword. So we will talk about this a little bit later in module 4. But for now, just let you know that for strings, we have two types of it. So one is called text, one is called keyword. And text means that we are talking about something like if you have this word inside the whole message, all right, within this message, or I would say, we bring it out. But when we talk about keyword, we're talking about apple-to-apple match. So basically, remember, yesterday we kind of like have a discussion on that as well. So apple-to-apple match is one of them. But usually when we talk about search, we're talking about full text, which is how relevant your search terms are comparing with this whole message, all right? So that's why you can see when we're using a filter with a match clause in the normal text field, we actually bring back a lot of things rather than just brewing in beats. We also got some like currently in Kibana, the last one here. The major reason is because, yes, you have one word matching this currently in Kibana, and the word is in. And so that's why we also bring this document out. So usually this is not what we want, because when we talk about categories, we want the apple-to-apple match. So in this situation, we should use the keyword field, okay? So just a very simple idea is keyword fields are for apple-to-apple match, exact matching, all right? Same punctuation marks, etc. And on the other hand, if you're talking about did any of these subwords appear inside this passage, that is what we call full text search. And then we'll be using the text field. All right, so that's the simple answer. So later on, we'll actually talk about on the score itself. That is how relevant it is. All right, for most situations, relevancy is a very good sorting criteria because we want the most related documents to be listed, right? Usually that is what we want. But there are cases that sometimes we might want to reorder the documents in another way. For example, based on date descending order. Now take example, when we're talking about security, right? Security things should be up to date information. So yes, you might say it's like, I found some antivirus related information about security, right? So like the viruses, right? To be honest, maybe you got some records that is displayed on page 1 that is talking about a virus called Michelangelo. So if you are old enough, you heard of this virus before. So I think it's around 1980s when Michelangelo is kind of like spreading worldwide. Because when we play pirated games, right, we use those floppy disks. They usually have Michelangelo inside. All right, it's kind of like that kind of situation. Now, the case is Michelangelo might be something super relevant to your security search term, all right? But the case is that was 1980s. Now it's 2021. So we rather want to display things based on the date nearest to us instead of like 20 or 30 years ago, in which, yes, they are very relevant, but come on, they are not very useful to me, all right? So that's why we might want to reorder the documents by other fields. And to reorder the data in different ways, we actually will need to add the sort clause. Now take example, we sort by published date this time, order descending order. And so that's why now you can see all your records are reordered in a way that the latest published dated document should be at the top. All right, and following with the coming days, etc. And also one interesting thing is if you're sorting based on another field instead of a score, you will find that all the scores inside the hits will be 0 or actually null. All right. The reason is because now you're sorting not based on a score. So why should we calculate the score for you? Because calculating the score requires TF-IDF calculation. It also uses up a little bit CPU cycles. And so if you're totally not using that, we will skip that part. So that's why if you're not using the score to sort, we will not even calculate the score for you. slightly faster. All right. You can also sort on multiple fields, just like normal SQL, like select star from table, order by this and that, etc. So it's pretty much the same thing, but the syntax will be a little bit more bulky. So you can see we'll be sorting based on author and then publish date. And so every hit that you return, we should also be showing you something like this. For example, the sort order. All right, so now because we're sorting by the author name and then the publish date, then of course you will see something like the author name at the top, and then the corresponding date, which is in epoch milliseconds, like that. So it's kind of like a hint to you to let you know that why we have this ordering, because we are sorted by these criteria. Now, the final piece of this lesson is talking about paginations. Now, paginations is talking about something like this, right? You will be shifting to different pages, okay? But how do we do that, all right? Now, it actually lies on two parameters to make pagination work, from and size. Now, take example, if the size was 10, all right, which is actually a default size, but then you might say, hey, I want to display more than 10 records per page. So you can actually change the size to 20, for example, right? So that's talking about the first page. But then how do we do the pagination? If we want to do pagination, we need to add one more parameter called from. By default, from is always to set to 0, which means that we always have from the beginning. So that's why we only return the first page. But if you want to go to the second page, you need to set the from exactly to the value of the size. For example, if the size was actually 10, then to page 2, we'll set the from exactly to 10. So then we're starting from the index 10, counting for the next 10 documents and bring it out. So that's how we do pagination. And so going to page 2 will be like this. Going to page 3 will be having a from set to 20, etc. Keep on going. But like one of the students said yesterday, there is a limitation based on size and from. The limitation is 10,000 documents. So we can't iterate indefinitely. So if you match something like 10,000 documents in total, we stop. All right, so that's the idea. So this is how we do paginations, using changing the from in general. We've gone through this a little bit earlier in one of the demos when we talk about highlighting. Now, highlighting is a way to let us understand that why this document matches your criteria. The syntax is very simple. You do a normal match query as usual, and then inside you have to highlight and tell me which field you want to display the hints. So in this case, the same title field. And so you get back something that is wrapped in between EM tags. Okay, so anything that's matched inside EM tags, they are the ones that match your criteria. You might say, I don't like EM tags, I want something else. Yes, you can do it by adding the pre and post tags. Now, if your pre text is kind of like yes hit, the final result will become yes hit, wrapping the corresponding hint value. All right. So that's pretty much for this lesson. So quite simple. Now, if you're a developer and you want to know the code, etc., I think you can actually get all your code here. I think it's home Ubuntu search page. Okay, so if you want to know how this so-called web page demo is written, you can directly go to this folder and read those source code if you want. All right. I don't think we supply the search code for you. If you want to, you can copy and paste or whatever. But you can just take a look if you're interested in it. So the so-called secret is actually all inside the config file here. So these are the connection URLs and also the corresponding URL for connecting to the PostgreSQL to do a search, blah, 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 etc. Let me see. There's also a new one. even though I think it's pretty much the same. Only the PostgreSQL part is different because there's no idle time, I think. So let me just take a quick look. There's only some changes on some parameters on the PostSQL, I think. Server 10. We have server 10? We don't. I think it's server 1. But anyway, so that's pretty much the idea. So you can just grab SSH into it and then take a look at the source code if you want, all right? Okay, summary. Okay, second point, sort is by default using score. Okay, so if you're not using score as the sorting criteria, you need to change by setting the order clause, actually the sort clause, sorry. All right, so then you can change how to do the sorting. Mhm. And if you want to do paginations, the simplest way is to use something like from and size. But even though we tell you that there is a limitation like over 10,000 docs, usually it's okay because when we do paginations, we do not do something what we call deep paginations. Usually, like in Google, right, they display you only maximum 25 pages only. So you can try later on in Google. If you try to go to do paginations, will be stopped at exactly page 25. You cannot go to page 30. So that is also a reason why Elasticsearch also does the same thing. So when you go into deep pagination, a lot more resources are allocated just to do this traversing. And so not just us, but also Google will stop you from doing that. All right. So that makes sense here. So it's not our problem. It's not because we're weak. Actually, every search engine does the same thing, right? They will stop you from deep pagination. Okay, so the two parameters that you can implement to do simple paging is from and size. Okay. Number two, search results are always sorted by score. I would say by default it is sorted by score, but we can change the ordering by using a sort clause if you want to. So that's why it's not totally true, but I guess the official answer here is actually true. All right. Number three, what's the difference between using cat and cat.keyword? Now remember, cat.keywords talk about apple to apple match. So everything must be identical except matching. All right. Then we would bring it out. So in here, we're talking about bringing all the categories that is exactly called user stories. But for the left-hand side one, we're actually using the text field. So that means if the category contains user or contains stories, bring it out. All right. So you might get back some strange things like maybe user cases instead of user stories also as a hit. All right. Now we've just gone through this module 2, and let's take some time for a break or rest or whatever. And we'll come back around 15 minutes. So now 30, 40, 15 minutes, 55. So we come back around 6:55, and then we'll start module 3, talking about aggregations. Okay, now we talk about module 3, where we talk about aggregations in general. So we got 3 chapters, so we might end a bit earlier, so or we might actually continue to module 4. So instead, I'll free you guys up on the last day instead. So for aggregations, we typically have 3 types of them, like for example, metrics, buckets, and combining metrics and buckets. Yeah. So metrics is something related to numbers in general. Now take example, the kinds of questions that you can answer through metrics is these things, like what's the number of bytes served from all blocks? What's the average response time? What's the median response time? Or what's the 95 percentile of response time? So all these things could be done through metrics. All right, so this is just the Kibana metric app, right? So later on, I can do the demonstration as well. But to be honest, metrics are just related to numbers. So you have a big data set, and there must be some number fields, etc. So we want to calculate a number based on this field. Now, Kibana visualizations under the hood. So this piece of information will be showing like nearly in all the metrics and aggregations related modules, right? So let me see. Okay, yeah. So basically, the aggregation syntax is quite similar to the search one, but this time you can see we are not using a query clause. Instead, we're using AGGS clause. Okay, so basically, all the AGGS required a label. So you can just randomly give it a label or make it something like much more meaningful. Like for example, they'll use numbers like 1 or 2 or 3. It doesn't make sense because you will not know what these results are representing later on. So usually we just give it a normal name and that's it. And then the corresponding aggregation types. So take example, AGGS, and then you give it a label like total sum of bytes. And then you provide the function here, for example, sum. And then which field you're talking about. We're talking about response size. And so the corresponding results will return you the top 10 hits, okay? Plus the corresponding aggregation results under your given labels. So that is the reason why I say the label names are important, because you typically want to have a meaningful name. All right, if you give it something like 1, 2, 3, something like that, yes, they will still be grouped based on this label, but you might not know what they are until you look back into your queries. Then you will know, oh, so 1 is talking about terms of category, and 2 is actually talking about maybe terms of author names, right? So typically that's not a very good idea. So instead, at the very beginning, give it a meaningful name so you know exactly what these informations are. Now back to this page, right? We return you top 10 hits by default because by default the size is always set to 10, but this is actually not very performant because think about it this way. Aggregations are talking about the statistics. So we're going to get back the stats, not the actual documents that form this stat. So that's why these top 10 hits, we never touch them. So there's no point to return these hits then. So that's the reason why for most cases, when we run aggregations, we set the size to 0. Simply, we return 0 hits because you never touch them. You never use them, all right? Instead, you just need the aggregation results, all right? And so now you see when we set the size to 0, search will be faster. Plus, you have an empty hits array here. So if you look at the hits.hits, it's actually now an empty array because we didn't return any hits anymore. Now, scoping. Scope is very important because if you do not scope, that is not apply any filters, for example, you're taking every single result inside your index to calculate the aggregations, all right? So that's actually not a good idea because usually when we talk about a very huge data set, we should be applying some filters, that is to get back the ones that we are interested in, and then we apply the aggregations instead of everything. So take example here, we're just kind of like filtering out data that belongs to France and then do the aggregations. So this is much more realistic in general. Now, some other questions. We can answer some of these questions by running the aggregations with the correct type. Now, take example, if we're talking about like finding smallest number of bytes in a response, we simply use the mean aggregation. So mean and then a field response size, done. When we talk about the biggest number of bytes in contrast, so this time we'll be using the max. So what about average? Average will have AVG as well. Now, the next question, what about median? Median means exactly at the 50th position, that is 50%, exactly the middle value. So to be honest, we do not have something called median, but instead we have something called the percentiles. Now, percentiles is like we reorder the data based on a field. In this case, runtime milliseconds, from the smallest one to the largest value, right? And then at the 50th percent, do a chop and grab back that value out. So that's how we get back the median value. So you can see it's not just 50%. We can also provide other percents like 25, 75, etc. So then we will do the chop at those intervals and grab back the actual value exactly at that point. So that's how we calculate the median, as well as something like the, it's actually useful for calculating some bell-shaped distributed values as well, right? Cardinality. Now, cardinality is talking about something like distinct counts. So if you were SQL person, you will run something like select and then distinct count of a field from some tables. So that's exactly the idea about using cardinality. So for us, we're using an algorithm called hyperloglog++. Okay. The reason is because we're talking about big data. You can't see my slide. Refresh the browser tab. So you can try to refresh the browser tab. And also on your top left-hand side, please also click on the follow the instructor. Okay, if not, you probably might not be able to get it. Yeah. Okay, so let's continue. So cardinality is talking about distinct counts, right? So we're trying to get back the number of distinct values within a particular field. And why we're using hyperloglog++ is because we're talking about big data. So typically, we won't be taking every single piece of data to calculate this distinct value, all right? Now you can think of it as like, if we're talking about database, maybe just some thousands of database records. It's okay to take every single document to get the distinct value. But when we're talking about billions and millions and billions of documents inside a big data set, we won't be taking each of them. Instead, we take sampling, all right? So the sampling will be based on this hyperloglog++ algorithm, all right? So usually it should be fine because we're talking about if you have some very extreme values, usually in a very big data set, they will be kind of like average on this so-called extreme value. So that's why making samples usually will not deviate too much on accuracy, all right? And so that's the reason why we use this algorithm. And the last point, it trades the accuracy over speed. So the major reason is because we're doing sampling. We're not talking about like every single individual document, bring out the field called countries, for example, and then do a distinct count. So that's why there might be a little bit deviation from the accuracy, but usually it's kind of like acceptable in most cases, all right? And also common sense. What's the point to do a 100% accuracy distinct count on a huge data set, all right? So because the data set is so huge, you're actually not thinking about the accuracy percentage. Instead, you're thinking about is like, how can we make use of these important values instead, all right? So that's why it's kind of like a trade-off. But if you really want to have 100% accuracy, you might need to integrate Elasticsearch with Apache Spark. All right. And we see every value on cardinality. What do you mean by every value on cardinality? I don't understand. Oh, you mean you want to know exactly the values, right? Here you say 200 countries, but can you get back the 200 countries names, right? So for this case, you won't be using cardinality. You will using the terms aggregation, right? So terms aggregations will re-separate this. Yeah, they will re-separate this into the top 10 most popular countries instead. Yeah. So if you want to know the values, you are using terms. If you just want to know how many distinct values are available, you'll be using cardinality. Okay. Cardinality is the number. Okay. And terms aggregation is talking about the actual values. Okay. So in the next aggregation lessons, when we talk about bucketings, we actually will go through that. All right. So we're talking about terms in the next one instead. Okay, so for now, just understood that when we talk about cardinalities or even terms later on, it's not 100% accurate because we're doing sampling. But for most cases, they are acceptable. All right. So before we move into the summaries and so on, let's have an idea what that Kibana was actually doing just now. So let's do a screen share. Okay. Now, usually when we run the aggregations, we will be using this Dev console to do it. All right. Now, as usual, if we just run the blocks, all right, we do a search and assume we don't do any size change here, you will return top 10 hits, all right? And then we start the aggregations part here. Now, the name is actually the label. Usually the label, we should have a better name for that. And for now, I'm just doing something like I'm trying to get back, let me see. So what kind of numbers do we have? Maybe we don't have numbers in here. We don't have numbers here. So I'll use another data set. So I'll be using get log server 1 instead. Okay, for log server 1, we do have some number fields. For example, the runtime milliseconds, that's one number field. We also have others, probably the response size as well. All right, so let's use response size. So aggregations, right? Give it a better name. For example, I'm going to the average of response size. So remember, this is a random label you can apply, but usually name it with some useful, meaningful names. Like, for example, the average of response size. So now I directly know what I'm trying to get. And now the type BBG here. Corresponding field will be response size. And when I run it, it takes some time. You see it take 919 milliseconds. All right. And we also got back the top 10 hits. All right. Collapse it, and then we get back the average. So the average is this number. All right. So to just copy this here. So that's the average of the response size for everything. All right. Now, the second thing that we were talking about just now is the size. Because you see, I just want this number. I never touched the actual documents. I never want to know what composed of this so-called average value. So that's why there's no point to return the hits in most cases. And so I will set the size to 0 and run this query again. You'll find that this time that we just need 54 milliseconds instead of 900 something. And the value is pretty much the same. All right. It's exactly the same number. All right. That proves everything's the same. All right. Changing size doesn't do anything on do not affect the final results. So this is one of the things that we can do. We can also run multiple metrics at the same time. All right. Let me see. I am here. Okay. So I can actually add another one. For example, a minimum of response size. And then I'm going to run a min. Right. And again, response size as well. So now all the results will return not just the average, but also the minimal value for the response size. All right. So typically, you can also run the max if you want. Max. And so now you get back the average, the maximum as well. All right. So you can see max should be bigger than average, right? Because it's the maximum. And we average the values, and so that's why we get back something smaller. All right. That makes sense. And we also got the minimum here, etc. All right. So that means you can always have multiple matrices if you want. So that's pretty much like a normal SQL. You can select star from something, and then you can also run average, minimum, maximum on another field as well, right? Okay, so let me see what else. Yeah. Okay, so now let's go to Kibana. Okay, so this is how we run these kind of queries in general. All right, but what about if you are actually a graph guy? So if you're using a graph, you will be going into something like dashboards. I need to create a syntax, but it's okay. I just create something like that. Logs server. Because I'm first time using the Kibana as graph engine, so I need to add back the missing index pattern. And so now I can continue the drawing. Now, depends on which Kibana you're using, right? So the latest version, you will have to start with dashboards. Hey, what's happening? Okay, then you need to create one dashboard, and then you can start to create a new visualization. So it's kind of like hideaway. So in the old days, right? In the old days, it should be here, something like visualization, or maybe it's something like this, visualize, right? But if you're using the latest version, you will need to go to dashboard and then add a new component. All right. So here, let me see. We're talking about metrics just now. So let's go to the metrics. And because I only got one index pattern, so I will be using this. And we've got zero counts. Why? So if you were the first time using Kibana, remember, time is important. We're talking about 15 minutes ago. Do you have any raw data in? Because the data set is kind of like created some time ago, so it's not within 15 minutes for sure. So usually we'll make it something like bigger, like last 5 years, all right? And so we will get back some data, all right? You can also tune this value if you want, like last 1 year, or last 2 years, etc. But in this demonstration, I just want to let you know how how we get back data first, all right? And so by default, the metric is always a count, right? So that's exactly the same thing like what we're talking about later on when we do the aggregations. So most of the aggregations return you a count metric by default, unless you change it to something like minimum, maximum, median, etc. Right? So that's one thing. You can directly change this one and it becomes the max, and you do the update. So now you get the sorry, I forgot the field. Max of what? Response size. So now you get back something like this number. All right. So that's one way to change a metric visualization. But in general, we will actually also set this back to count first, and then add one more metric. So just like what we did in the Dev console just now, you can have a minimum, maximum during the query terms, right? So inside this app, you can also do the same thing by clicking on the app here. So now you have a new metric, and this metric is based on max, for example. Max on what? Max response size. And then another one. And this one is actually maybe minimum of the response size, and one more for the average. We got average here of the response size. And so now you should get back a bunch of different metrics. The count, max, minimum, if you still remember, minimum is 98, and also the average around this number. All right. So that's how we play with this visualization now. Now, the next important thing is you might also want to verify how we get back this result, right? So the case is you can always click on the inspect button here, and you will see some basic information about the metrics that we want to display. You can also download this as a CSV if you want to do integrations with other systems, all right? But the important part is I want to show you the request. And click on this request again. You will see that they have all the query contents here. For example, I'm running an aggregations call number 2. Okay, so remember, this is a bad naming convention. We should name it a little bit better, not number 2, maybe something called maximum response size. And you can see we're running max here. Number 3 is running a min. Number 4 is running average, etc. So if you do not know the syntax, you can actually go to any apps, draw something, and then inspect and look at what we've just created for you. So these are kind of like hints for you to know how to write the query. Also, size is again set to 0. Like what we said, we don't actually touch those hits. So there's no point to return. And so for Kibana, they also set the size to 0. So store the field, well, this one you can kind of like ignore for the meantime, because usually we don't need to set something like store the fields. And we do not run scripts here, so there's no script to field as well. Document values, so this one is talking about timestamp. So when did we play with timestamp? So we still remember we've changed to last 5 years, right? So this is where we get back the timestamp. And so based on the corresponding query part, you will see that we have a range query ranging from 5 years ago to now. All right, so that's why I say it's greater than equals to 5 years ago today, and today, August 03. All right, so that's how we kind of like range the data. That is 5 years ago to now. Or maybe you can actually use like now minus 5y, okay, greater than 5 years ago. That's also possible. But for computers, we typically would generate all those ranges for you. All right, so that's the reason why. And the format is actually using a strict format. So this is actually good to know. All right. And we also do a match all as well, because you didn't have any query criteria here. So let's do something. All right. Let's try to add a criteria. For example, maybe the country or country code. Country code is, for example, Indonesia, something like that. Do we have? I think we have. Okay. And we run it. So I need to run it. So you see, we just kind of like restrict the data that is coming from Indonesia and so on, the values will change as well. So the minimum is down not 98, but 186, because in that country, maybe the minimum response size is actually this value instead. And if you go back to the inspect again, you will see that now we have a new criteria updated. So everything at the top is the same, right? So still the mean, max, average, and so on. But here we will now add a criteria called the country code equals to Indonesia. And it's kind of like match phrase. And it will be should clause with minimum should match of 1. So all these things are actually useful for you to take into consideration. If you do not know how to write the queries and so on, you can start looking at these so-called generated code. Now, one disclaimer is these generated code might not be the most optimized one. All right. So for example, is there a need to write a Boolean query with a should clause matching Indonesia, this country code? Probably not. You can just directly run a filter match country code directly to ID. That's it. All right. So that's probably a much more easier way to rerun this criteria. So anyway, we will generate these things for you, and you can kind of like take into consideration if necessary, right? And the final piece is, let me see, there should be a response as well. So these are the results, and you can see exactly similar to what we did in the Dev console just now. So you get back the corresponding labels and the corresponding values. Now, this is the reason why I say you should have a meaningful label, because you get back something like a number, but what is this number representing? no idea, right? So that's why if you have something like more meaningful, like maximum response size, now you know, oh, so this is the maximum value of a field called response size, all right? Instead of something like 2, 3, 4, all right? So if you don't know what's 2, 3, 4, you need to go back to the request and see, oh, so 2 is a max, 3 is a minimum, 4 is an average, all right? So that's the idea. So remember, if you never know how to write the aggregations, try to use some of the visualization apps here, okay? And then pick those code behind, right? So that's the case. So we'll just go back to here and yeah. Is can also search multiple field, maybe minimum response, another field. I'm not quite sure what's the question about. So what do you mean by search multiple field? Minimum and max. Oh yeah. Oh, so this one, yes, of course. I know what you mean. So again, let's go back to the Kibana. Now I'm just using the same field, right? But we can of course use other fields. So are there any number fields? Okay, we have runtime milliseconds, so we'll use that one as well. Now take example, we're getting the minimum runtime instead. So the minimum runtime is 0. Okay, so maybe average. We want to have some values so that it seems like something normal. Okay, so you can see here, when we're talking about the average of runtime, we have this number. All right, so it's possible. So we are just taking we're just taking different fields to calculate a metric number. All right, so it's possible. Also, one more thing, when we talk about the filterings just now, right? Like I said, usually Kibana will try to generate some query criteria code for us, but they might not be optimal. For example, in my case, if I just want to do a filterings, like for example, based on Indonesia related values and so on, I can simply just run a normal match query here. All right, that's it. And boom. Now the values were very different because we are averaging. We're maximum averaging on only Indonesian records. So that's why you get back this number now, 269960. All right. And of course, you can have multiple fields as well, right? So again, you might want to have the average response size as well. And so you will also get better average response size based on the country and runtime. The runtime millisecond is actually the same, is it? How come? Response size, hey, let me see. I've got 2 of them. Hey, where's the runtime then? Okay, yeah, you're right. Because I'm having twice of them. So that's the average for the response size. This one's for the runtime. Okay, that makes sense. Yeah. So you can see here, we can have multiple values to run the metric as well, as long as you need it, right? Okay, back to the summary. The matrix itself, right, is basically calculating a number. Okay, we're not doing segmentations and so on. We're just calculating a number. That's it. And percentiles is talking about like there's a way to reorder the data and get back exactly at the in percentage what's the value of a particular metric number. All right. For example, median. Cardinality is talking about distinct counts. But remember, the accuracy might not be 100% sometimes, right? Okay, question 1. You can choose arbitrary names to identify the clauses in the aggregation. Yes, it's a random label. But remember, do not use something like running number like 1, 2, 3, 4, 5. Does not make sense because later on when you get back the results, you need to check. All right, so what do you mean by 1? Okay, so 1 is maximum of something. So that's kind of like not very efficient, all right? Especially when you are the one writing the query, but somebody else is the one that's going to read your results. So they have no idea what the hell you're doing, all right? So that's why you should use a better label. Yes, arbitrary names is okay, but meaningful names. So question 2, we'll skip. So this one is talking about like percentiles plus a query as well, because we're talking about less than 100 milliseconds. So we need to have a query to filter out all the records that is within 100 milliseconds in response time, and then to run the 95 percentile to declare if, to get back the values, etc. So that is actually how we do it. Okay, the last one. The last one is a very tricky one. So they were asking what kind of queries and aggregations you should use to answer this question. Like how many unique visitors came to our website today? So the first thing is, how do you know these records come from today? So you need to have a timestamp field, right? So maybe something like visit date or last update by at or something like that. So you need to have that field. And then the next thing is you need to run a query to filter out all the records that is within today, all right, based on that timestamp field. And the next thing is after you have this subset, run the cardinality, all right? So that's why you will need to have queries and aggregation parts together to solve this question, right? So again, let's take some time for a rest and we'll come back around 15 minutes. So now is, okay. So let's come back around this time. And then we'll continue to lesson 2 when we talk about the bucketing. That is segmentation of your data before you run something like metrics. So let's come back around that time. Now this time we have one segmentation called every day. So earlier we do not have something like every day that kind of segmentation. We're talking about everything. All right. So that is one of the differences. We can also ask some other questions like how many requests took between a particular range, like 0 to 200, 200, 500, 500 plus, etc. We also can find out what are the most popular values, like for example, the 5 most popular block categories, etc. So all these questions can be answered through simple bucket aggregations. Now, in general, bucket aggregations will be able to draw out graphs like this. So because we're not talking just about the numbers, but also based on some groupings of data. So based on different groups we created, eventually we can draw them as a chart. All right, so usually much more useful. So the same thing. So in the previous demonstration I've done, right, you can always draw some of the graphs later on in some visualization apps, and then take a look on the inspect source and know exactly how we write this aggregation. So the idea about buckets is segmentation. So how do we separate the data in general, right? So take example, you can separate your data based on month, all right? So that you have like April 2017, May 2017, etc. So that's only one way. So usually when we talk about something like separate your data by dates, we're using date histogram. So you need to provide a timestamp field, that kind of thing, of course, right? And you also need to tell me exactly what is the interval to do the breakage. So for example, this one is per day level. You can also provide something like per month level, right? MONTH, or even yearly, or maybe something like 3 days, right? So 3 days, you provide something like 3D, all right? So D means days. So based on the interval you provided, we will do the separation for you. So this is the idea about the response. So usually the response will provide you the key and the corresponding counts. So remember, every bucket aggregation by default returns you the count, right? But this is the default metric unless you specify. All right, so that's exactly the same case when we do the metric drawing just now. So you can see by default, they just return you number of counts, right? And so the interesting thing is the key here is a number, something like this. So this is the epoch. So epoch simply means the number of milliseconds since 1970, 0101 midnight. So that's why usually it's a positive number because we're now 2021. So we are actually far beyond 1970. So it should be a positive number, all right? Unless your dates are somewhere like earlier than 1970, like 1965, then it will be a negative number. So, however, this epoch number is not very human readable unless you have a translator to translate this value. So that's why we also give you the key as string. So now you can see something like YYYYMMDD, right? So, however, if your field that is going to do the bucketing is based on a number field instead of a date field, you can actually use a normal histogram. And this time, the interval will be just a normal number, right? Like 100 or 10 or something. There's also a very similar aggregation called range as well. So the differences between range and the interval is, you can see interval is a constant differences between the units. For example, 100 units is one result set. All right, so that's what we call histogram. But when we talk about something like range, right? Range is talking about some user customized range values. For example, 0 to 200. And the next one is 200 to 500. The next one is 500 plus. So this is when you might use something like a range aggregation. Now, one use case I can think of is like related to insurance. So insurance is like this, right? Different age groups, you need to pay different premiums, all right? And so for babies, that is like maybe age of 0 to age of maybe 10, something like that. The premium is very high, very expensive. But starting from 10 to maybe 20 years old, or maybe 30 years old, usually the premium is much more cheaper, all right? The major reason is because usually starting from 10 to 30, you're actually growing into some healthy kids or maybe teenagers, all right? But after that, like maybe after the years of 60, you are actually kind of like very dangerous to this insurance company because you are typically facing some disease or you might be going back to heaven or whatever. So that's why starting from the age of 60, the premiums will be very high again. All right. So kids, I mean babies, infants, and then to the and also the elderly, they're usually the most expensive groups. So that's why you might want to regroup your data based on the different age groups instead. So that's the reason why we will be using a range aggregation instead of something like a normal interval, because all these premiums are not really based on some constant differences. Like for example, units of 10, like this. Instead, it's based on the business logic. So this is when we use a range aggregation. Okay. Right. So what about terms? So just now there was a question. It's like I got the cardinality of how many countries we have, but I want to know the actual values, right? So the actual values are available through using terms aggregation instead. So this time we are grouping the buckets based on the values of the country name. So now you get back the top X countries instead of just a number. So the syntax is quite simple. You just use a terms aggregation, you use a corresponding field, and then you give a size. So by default, it's also 10 pieces of the information, all right? But if you want something else like 20, just add back the size here. So this is the result. You can see that we have all the top 5 countries in this case, as well as something called the sum of other document counts. The sum of other document counts is also makes sense because inside the 202 countries, you're just displaying the top 5. So the remaining 150 something countries, 190 something countries, what's the value? So you might want to kind of like display this thing as well. So that's why we use something called the other buckets. So all the other countries' values will be inside this bucket here. And if you look back into the graph, you will see that the others is actually also quite big, right? It's kind of like the second biggest piece of the information inside this graph. Now, terms aggregation also help us to answer some questions like what is the most popular in values inside dataset. For example, the most viewed blocks, right? We can simply use the field original URL, and then you get back the top 10 blocks URL that was visited most recently, okay, and also most popular inside the period of time. So if you change it to like category keyword of 5, that means you're taking the top 5 most popular block categories. And for offers, then you're actually looking into the top offers. Now, the last piece of the information for bucketing is sorting. Now, usually sorting is kind of like optional, but sometimes we might want to resort the order by some other criteria. Now, the important thing is different aggregations have different ways to sort the results. For example, the date histogram is always based on the date ascending order, all right, instead of based on the number of counts, etc. And for the other ones, like for example, terms aggregation, they are always sorted by the numbers of counts, descending order by default. So instead of like sorting by the term's name instead. So that's why you can actually change the ordering by adding the order key here. All right. For example, based on the key ascending or descending, or maybe the counts ascending, descending, etc. So again, a very short demo on what kind of aggregations we can use in Kibana to represent these bucket things. So let's start with the normal Dev console first, right? So take example when we talk about like getting back the top n results, all right? You can run the blocks. So remember, size should be set to 0 because we do not need to access those things anyway. And we will be talking about like countries, right? Maybe top 9 countries. So we're talking about terms aggregation on the country code. Oh, we don't have. Okay. So maybe categories then. Okay, top 9 categories. Or maybe just top 3 then, because categories we have not too much values. So here, the size by default is 10, but we can change it to 3 only. So now we get at the top 3 categories, which is engineering, empty string, and releases. So now this is the same thing. When we see something weird like this, right, we probably want to ignore these records because they do not have a category. So again, add back the query clause. So this time, I'll be using something like, okay, something like Boolean query, and I'll be using a must not because I want to filter out all the things that is exactly empty string for the cat value, right? So I'll be going to category keyword, give an empty string. Doesn't work. Let me see. Let me see. That's a very difficult thing because Elasticsearch has a very stupid functionality on empty strings. Okay. Anyway. Okay. Okay. We actually did it. Okay. Not matching this. It still works. All right. Even though it's a little bit strange. Okay. So you can see now when we filter out all the empty string categories, now the top three becomes engineering, release, and something called the this week in Apache Lucene, blah, blah, blah. All right, we've got 156 counts on that, right? So that's how we do the aggregations on bucketing here, all right? But what about in Kibana then? So in Kibana, okay, it depends on what kind of operation you're doing. You choose the different kinds of graph. So I think the easiest one to understand is actually a pie chart for buckets. So by default, I got everything here as usual. I'm going to do the blocks, right? Sorry. So I need to add back the blocks as well. So let's go back to stack management. I need to add the box index pattern. Okay, now we can draw the graph. So remember, for Kibanas to work, you need to create something called an index pattern so that the graphs know where to get back the data. For example, from blocks or from log server. So for us, we're using blocks just now. So we'll be using this. So we got every block here, 540 blocks. Probably more than that. So I think it's 15 years. We should have 1594. Okay, so within 15 years, we've got exactly this number of blocks. Good. Now, how do we do the segmentation? The segmentation is very simple. We add a bucket here, split it by slices. Usually, we will use a term segregation for this kind of scenario. And we want to separate them by the categories. Now, we are using 3 just now, so we change this to 3 as well and run it. So these are the 3 things. We've got the engineering, we've got the releases, we've got the empty string, blah, 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 etc. So let's try, right? Because Kibana, they don't let you directly use a query, right? And so let's try. I forgot the syntax as well. So maybe something like this. Category keyword equals to empty string, and then not it. Let's try. Okay, it worked. Good. So here, what I'm doing is using the query string. We're talking about like the category keyword if it equals to empty string, and then not it, which means must not be having empty string. So then we kicked out the empty string category, and we got back engineering, release, and the week in Elasticsearch and Apache Lucene. Okay, so that's pretty much how we create the same aggregations under Kibana. But one more thing, just now we were talking about the others, right? So when you look into the configuration, there is some button called group other values in a separate bucket. If we do so, you have one more others here. And the value is 427. This one is 420 something. So that means the remaining values, the category values inside this data set will be grouped in this piece. All right, so this is an optional thing. You might want it or you might not want it. So typically by default, we do not include this one. So we just show you exactly the top three in this case, right? The same case, you can always go back to the inspect and take a look at the request. And this time you'll see that we have an aggregation call number 2, again, a very bad naming convention. We're going to do a term aggregations on the category keyword descending order, okay, size of 3. So that's exactly what we did in the dev console, right? So just now here, we're actually running something like this. The only thing I miss is the ordering. But again, it doesn't really make too much difference in this case, all right? And the other things is talking about the criteria, like for example, range from 15 years ago to now. And also there is also a category keyword not equals to empty string, right? So that's why there is also a Boolean query with the phrase something like this. So again, remember, these generated code might not be the most optimal solution. So in my case, I just simply run a must not. That's it. They also run the must not here, but the must not is wrapping on top of another Boolean query again. All right, because by default, they will run a Boolean query with minimum should match of 1. So that's why it might not be the best optimal uh, free syntax, but at least you have an idea how to write this thing, right? Let me see, anything else? Okay, for now, we'll just stop here, right? So in the next lesson, we'll actually talk about some other things about buckets plus metrics, okay? So in general, the summary is a bucket is just a collection, or maybe we would say a segmentation of the data set by some different fields, all right? Term segregation is powerful because you will be grouping the data based on a particular string value, and you also can help to solve the problem of finding the most popular um, things within the data set. For example, if you're using a category field to do the terms, you actually will be able to get back the most popular terms values inside the data set, etc. You can also use the order to resort the data set eventually. All right. Okay, question one. What aggregations would you use to put the login events into buckets like error, warrant info, etc.? So this is usually terms aggregation, right? So the second one, what are we trying to do here? So the first thing is we have a range applied to the data set. So we're just bringing that whole year's data, 2017 out, and then we're running a data histogram based on per month level. So we want to know exactly per month of 2017, how many records are available per month. All right. For example, we're talking about how many blogs are published per month level within 2017. So this is what we want to do here. So again, let's take some time to rest, and we'll come back to the final lesson for this module, combining metrics and buckets together. So roughly around 15 minutes again. So this one will be 23. So X623 will come back, and then we'll talk about the final lesson here. Okay, so let's stay tuned for that. Okay, so the last piece of the aggregations module is talking about combining metrics and buckets together. Now, to be honest, for most cases, right, having buckets or having metrics is, well, good, cool, but they're not very useful to solve the day-to-day real problems. One of the reasons is because you actually can segmentate the data by buckets, but you probably don't just want the number of counts. You want something else, right? So that's exactly when you're going to add back the missing matrices. Now, take example, like we're talking about something like what's the sum of the bytes per day. So segmentate the data by daily basis and then get the sum of number of bytes. So this is more important in general, all right? So again, combining all these things can actually draw different kinds of graphs, right? Now, the power of your aggregations is because you can always combine the metrics with the corresponding segmentation methods through the bucketings. Now, take example. We bucketize our data by date histogram, that is daily basis. And then in the daily buckets, we actually not just get the counts, but also the sum of response size. So in the corresponding results, you will see that we actually have two values coming back. The daily sum of the bytes in number of counts. So that's a dot count here, 252. I really don't like this environment because it's very difficult to select. So you can see that we have a dot count of 252. At the same time, we also got the daily number of bytes with the value of 1.5 times 10 to the power 7. All right, so that means number of counts are always there, but we also provide you additional metrics if you need them. So you can also have like multiple matrices as well. So we've already done this kind of thing a little bit earlier in the first demonstration. You can see that we can have a data histogram. Underneath, we can have multiple aggregations like the daily sum of bytes. All right, that is a sum, and also a median, like using a percentiles. We can also do a sorting based on metric as well. So you can see when we do sorting by metric, we're talking about like you get multiple metrics returned from the previous aggregation. We want to use that metric value to do a final sorting. So that's why I can see here, the order will be daily sum of bytes. And so you might ask, what's daily sum of bytes? So daily sum of bytes is one of the metric aggregation results. And we're using that result to do an ordering. All right, so this is actually achievable, even though the syntax is a little bit, difficult to understand. But based on your experience later on, when you keep on using the aggregations and sort, you'll be able to do this kind of sorting, right? Because you already understood what this syntax is about. But for now, it might be a little bit confusing, right? And buckets can also be subdivided as well. So take example here. We divide the data by the date per month, and then we divide them based on the server's name or the host name, all right? And theoretically, you can keep on separating the data based on different criteria until you reach a bucket that you're flavor in, and then run the metrics. So remember one thing is metrics is always the last level of aggregations. So on top of it, you can have multiple ways to re-segmentate by bucketing, all right? But at the very end, there must be only metrics, okay? So that means you can't do a metrics and then suddenly say, hey, let's re-separate them again. So you can't do so. So only separate them at the very top. And once you meet the piece of information that you want to kind of like create a metric, okay, that is when you apply the metrics, which is the last level. So sub-bucketing in this case will be in this syntax. You have a day histogram, monthly interval, and then you have the sub-aggregations here using terms aggregation of another field called host name. And the results will be something like this. You have the first level buckets, which is key as string with the corresponding month value. And then you have the sub-level aggregation with the host name, right? Like server 2, 3, and 1, etc. Now, there's also some other interesting aggregations that you might want to touch. So this one is talking about top hits. So when we stop to create aggregations like terms aggregations on the author field, we only get back the number of counts by default, right? So that's exactly what we've learned. Now, the situation is sometimes we might want to know exactly 69 records from Suyok, this person. What are they about? Can I actually have a sneak preview on what is actually inside this 64 records? So this is when we're going to run some like top hits. So top hits is talking about like, hey, inside these 69 records here for Suyok, can you bring me the top 4 records so that I do not need to run an additional query? All right. If not, you need to run additional queries to get a size of 4. Then you know the top 4 records from Suyok, etc. So it's kind of like a better way to make sure that one go of queries can bring back all the information you need. So the results will have the person, Suyok, with 69 counts, but also the top 5 results of this Suyok person. So pretty much one of the last piece of this information is talking about something called significant aggregations. Now, significant aggregations is like this, right? So let's play a game maybe. So if I am kind of like asking a question, so did you use the website Google last week, something like that? If I ask, did you use Google last week? So probably most of the people inside this class will say yes, right? And also, if I go out of this classroom and ask somebody else, did you use Google last week? Probably they also say yes. Okay, so more than 60 or 70% of the people say yes to using Google. Okay, that is the normal situation. Now, this is the interesting thing. That means within the classroom or outside the classroom, people just use Google. So Google simply means something popular, right? So there's no special meanings inside this classroom or outside the classroom. Now, if I change the question a little bit, like, did you use the Elasticsearch website last week? So maybe in this classroom, assume 60% say yes, right? Because some are managers, they don't need to actually dive into documentation. Okay, so they just order people to do it, so they don't need to access. But for most of the DevOps people, they need to access the official website for clues and documentation, APIs, etc. Okay, so within the class, 60% of the students or the people here say yes to Elasticsearch. But what about outside of this classroom? If you ask somebody what is Elasticsearch, probably not many people understood, especially when they're not doing IT. All right, so maybe less than 20% of people say yes to Elastic. So what is the aim of this game? So this game is talking about something like context level interest. Okay, now within the context of this classroom, Elasticsearch has some special importance to you because 60% of the people say yes, they use Elasticsearch last week, all right? But outside of the context, that is this classroom, typically Elasticsearch is not something popular. Only 20% or less than 20% of people said they kind of like visit to this page, right? So this is what we call significant aggregations. Significant is talking about within a context, what are the important, meaningful terms that we should focus on. And for the others, like Google, this is a very popular term, ignore it, all right? Because it's kind of like noise to us. Because everybody would say they use Google. So it's kind of like not very useful and not meaningful to represent this classroom, all right? So that's the idea about significant aggregations in general. So for significant aggregations, because we have a context, we can also do recommendations based on this group's interest. We can also do fraud detection because you can think of it like noises would be transactions related to normal usage. All right, like for example, inside credit card history, probably if you buy a lot from Amazon, having Amazon as an entry is something popular. But suddenly you found that you have another transaction with a unknown dealer, like for example, I don't know, something like GoGo Market, something like that. So you never heard of this thing before, but you have a transaction. So this is what we call significant values that you need to look into, right? So the idea is we remove all those Amazon transactions because they're popular, just noise. And the level of we take a look on the level of things and we found that, oh, so there's something called GoGo Market and you actually bought for a couple of amount on this market thing. For example, 1,000 US dollars. So something that is kind of like abnormal. So this is how we do fraud detection by using significant aggregations as well. So then, after knowing the theory and playing with the game, so how do we write the syntax? So the syntax in general is like this. We start with a normal terms aggregation, all right? And we found that based on a user called Monica, if we just run a normal terms aggregation, the normal ones, we get back strange words like ander. Doesn't really represent this person at all, just common terms. But when we shift to significant text, for example, we found that we get back like metric bit, file bit, beat, etc. So all these things are talking about what? It's talking about, if we're talking about this person called Monica, if we use the significant terms, so these metric bit and file bit represents her a lot, all right? Instead of something like ander, all right? Because if you're honest, ander is useless, meaningless. But if you see something like metric bit, file bit, you find that, oh, so this person might be a specialist on using these bit things. And so the truth is, Monica was actually one of the employees of Elasticsearch, the company. And she was actually the ingestion team lead. So she's the one that was going to make milestones and sort for the products called metric bit and file bit. And so that actually represents her very well, right? And so this is the power of significant aggregations. However, using significant aggregations is kind of like costly because you need to define what is the context, and then based on the context, you kind of like do some filterings, and then you do the final aggregations. So you need some extra runnings and CPUs on to make sure that the results are correct. And so this is actually costly. And that's why we would suggest you to do some filterings beforehand. Like for example, run the sample aggregation earlier so that you are taking less samples, and then you run that heavy significant aggregations, right? So like the last point said, this will improve your speed, memory usage, and quality of results, etc. Right? So there are some other interesting things talking about how significant terms aggregations work, right? So there's a block here as well. So before we end the class for this one, let's take another Kibana dive. Okay, so before we draw the graphs, right? So again, let's do some normal queries. Now, for example, log server 1, right? Size of 0. Remember, size should be 0. Aggregation. So this time we're talking about buckets, multiple buckets, and maybe bucket plus metrics, right? So let's do I don't know, let's take a look on the data set. What kind of things do we have? We probably have some country code here, like GeoIP. So what I can do is I will do a terms aggregation. We call that country. GeoIP country code to the keyword. So I'm going to take a top 10. All right, so that's the first level. So if I do a top 10, you'll find that we've got a lot from US, France, Japan, Germany, India, China, etc. So what I will do is, because I don't like US, so let's just throw it away. So I will also add back the query here as well. So we can add a Boolean query, must not clause, must not clause, and the country match country code 2 should not be US. All right. So now your final result will be skipping United States, but keeping the others, right? Even Hong Kong is here. Interesting. You can also remove a bunch of them if you want. For example, I also don't like France. So, okay, so just add something like this then. FR as well. And so now your final result sets will be excluding US and France. Very good. So that's the query part. Okay, so, and also this is the first level. Now the second level is usually somewhere here. Okay, now the second level of the term segregation is based on the city name. So again, we can use the term segregation, the GeoIP city name, and should it be top 10? I think maybe top 3 is enough because too many data. So now you would see every single bucket like Japan, this country, we've got accounts by default. And then we've got top three cities like Osaka, Tokyo, Kawasaki. And for Germany, it's Berlin, Frankfurt, and West. India is Mumbai, etc. China is Beijing. GB is Great Britain, so we've got London, Croydon, Kensington, etc., etc. So it's kind of interesting. Hong Kong, they have Mong Kok Central District, blah, blah, blah. All right, so Russia is Moscow, St. Petersburg, blah, blah, blah. So this is the second level. Like what I said, it's possible to keep on segmentating. So actually you can do so. All right, but of course, in my case, I would just kind of stop here. Now, by default, all these matrices are just counts, right? Maybe you want to do something else. For example, in here, probably I want to have a final aggregation based on the sum of response size so that I know how many traffic has been served for this particular city. So what I will do is I will add ETGS here. I would say sum of response. Okay, sum response size. And what we get is we've got the first level Japan, the country, and then second level Osaka, the cities, plus every city contains the sum of response served. For example, 9 times 10 to the power 8, 3 times 10 to the power 8, etc. Right? So this is how we match the corresponding buckets with your matrices. All right? That's exactly how we do it. Now, there are cases that sometimes we do not need to, sometimes we get back to the city like Mong Kok, etc., but we also want to know the details of the 6,000 records, right? We've got 6,000 records from this Hong Kong, Mong Kok city. We also want to know exactly what are they, right? A kind of like a sneak preview. So in this case, your aggregation will be using something called top hits. Like, for example, top 2 records, right? So I would just change this to top hits. And the size will be 2 in this case. And now, instead of like, wow, it takes so long. Okay, but anyway, it returned. But it took like 7 seconds. Let's run again. Okay, now it's faster. Right, you can find that now on the Osaka city, the top 2 hits were actually this document and this document that forms, all right, that forms part of this result set. You can also find that, okay, it's quite informative, but very bulky, right? Maybe I just interested in, like, for example, the host value, or maybe just the response size or original URL. So similar to normal search, we can add a source, right? So I would just include the response size and also the original URL. And so instead of returning everything, I'll just return original URL and response size here, right? You can make this response slightly less bulky, right? And also one more thing is we can also add filter paths, right? Filter paths is talking about this. Now, for example, we got so many other data that we do not need. For example, these metadata, or we can throw them away. So let's start with aggregations level instead. And now you see, we start from aggregations and no more metadata on top of it. All right. You can also do sub-levels, hierarchies. Like for example, I just want to grab data from country, and I also want to exclude all these some other blah 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 etc. So I'll just directly type in buckets, and so now you will have only the country but not other metadata. So again, you can keep on traversing it. I'm not sure if I can keep on traverse like this, but let's see, buckets, and then we've got a key, we've got dot count, we've got the CT. Let's try. Let's see, it seems to be working. Let me try. Actually it works, but the problem is when we run this .cd, we are also excluding a key and count here, so you can see, all right? So also excluding the city, the counts and the key here. So that's why usually we will do this, all right? Usually we have a comma here telling you what fields we want to include, right? And for example, here I will include the key, all right? So I'll have the keys here instead, sorry. Key, and I'll also need to have the dot count, count. Okay, so it's underscore count, I think. What? Dot count? Okay, it's dot count. And then I will also include the city as well. So now you'll be including just this part and the city part. And so the same thing, if you want to remove these other docs, etc., you will need to keep on adding the paths that you want to include. So in my case, let me see, I just need the city.buckets, probably. City.buckets, right? And for the buckets, I will need to have the key as well. So I'll be having this. Buckets, key, and dot count. And then I probably also need the other remaining things as well. Also need the sub buckets again, buckets dot key count, and then we need the top two records. All right, so now you can see most of the metadata are gone. We just get back the keys and counts and then the values, etc. All right, so this is how we can reduce the size of your final JSON, even though it's still very big, right? But comparing with the previous one, so now we should have 1,000 something rows. But if we do not add this filter, right? If we remove this filter, it's like 111.67. So I think it's more than maybe 50 or 60 rows more. All right. So that's why you can actually try to kind of like shrink or maybe to make this response a little bit smaller by this case. Now, the next piece of things that we can do is how do we convert all these things back into a normal graph? So simply, we go back to here. We found that we already kind of like divided the data by certain aspects, right? But in here, we're going to use the log servers again. So we're going to redraw this thing using the log server. Let's bucket this first slice by terms aggregation of, I think it's country, right? Country, code 2. I think it's 10 as I remember. All right, we've got the top 10 countries, right? US, right? So let's throw this thing away. Now, another way to kind of like create the filters instead of like typing commands here is by adding this filter bar. So here, I'm going to use the country code. I should use the country code .keyword instead. Yeah, country code .keyword, and is not one off. It's not US, it's not France. Okay, I'm happy. So save it. And now you see that the difference is there is no more US and France anymore. All right, so that's another way. You can use this filter to create the filtering criteria instead of like typing things here. All right, so that's another way. So now we got a top 10, and you can keep on theoretically slice it again, sub buckets. Terms again, city. As I remember, I'm just picking top 2. All right. So now you get a so-called sub-level. So this country got Japan, there are 2 cities. Okay, Osaka is one of them. The other one is Tokyo, etc. All right, and that's it. So for Kibana, there are some limitations. So for example, we cannot run top hits here. So if you run another slice, for example, there is no top hits. All right. So for Kibana, there are some things that we cannot do. All right. So if we're just using the normal normal aggregations on Dev Console, we can run top hits as usual. But for the graphs, we cannot do that because simply we're showing you something like a graph and not a data table. So that's why there are some limitations. So some of the things we can do it, but some we can't. All right. Okay, so another thing that might be useful to you is to click on the options here. We can convert this back into a normal chart instead of a donut chart. All right. So this is a traditional chart that we used to read. And also there are some labels as well. So when we apply to it, you can see that there are values and the slice pointers here as well. So this might be a very good idea for displaying or telling a story. So the last thing is the legend. So now it's by default on the right-hand side, but it's kind of like a bit too much, right? So you can make it at the bottom instead. So if it was on the bottom, well, it looks a little bit better, and you have more spaces to draw this graph as well. All right. So that's the idea about using Kibana to run bucketings with multiple levels, as well as if you want to, you can also do y-axis values. So the y-axis by default is also count, but if you want, you can make it to sum or average or something, all right? The response size here. The data actually changed, I think, but they don't change too much. But the values are here, so you can change. You can see it's changing. Unique counts of a field for status scope, for example. Yeah, so if I change the status scope and stop, it will just change. Like status scope 6. Well, all is 6 though. I don't know why, but all are 6. So there are 6 unique codes. Okay, status scope maybe like 200, 404. So typically they have 6 status scope. And this one is less. There's only 4 of them. All right, so that's the idea. All right, so it's actually possible. Okay, so that's pretty much the demonstration here. Okay, so I will skip the quiz here because all these things are actually just talking about how to use the metric and buckets together. So if you do your labs later on, actually we'll be doing all these things again. So I kind of like to skip this thing. Okay, so let me see. We've still got like 30 minutes time. Let me see. Okay, so let's take a short break again, and we will continue one more lesson today, or maybe part of the lesson because we still have time. So we probably won't be stopping suddenly. So let's take like 15 minutes. So now is, no, maybe 10 minutes. Now it's 50 something, 10 minutes. Okay, so let's come back around this time. Exactly at the next start of the hour, we'll talk one more lesson to see how it goes. All right. So for the meantime, if you want, just take a rest or do something that you're interested in. All right. So we'll come back around roughly, actually only 6 minutes. All right. Anyway, just take a break. Okay. Okay, so the last piece of the lesson that we're going to cover today is talk about Module 4, text analysis. Now, we again have like 4 lessons here, so we'll be talking about what is mapping. We'll be talking about the difference between text and keyword strings. We would also talk about the data structures that is related to text and keyword, that is inverted index and document values. Finally, we talk about customization about the mappings. So the first one is talk about what's a mapping, why is it important. Now, mapping itself is pretty much like a database schema, right? So if you were database people, you know that every table you need to have a schema, and the schema is talking about the name of the field, the corresponding data type, and that's it, right? But for us, we actually need more than that. We're talking about like the fields available, the data type, of course, but also how Lucene should handle our fields data structures. So that's why mappings is actually more than just a schema, but also kind of like controlling the behavior of your fields, right? So typically, if you have an existing index somewhere, you can actually run get index slash mappings, and then you can take a look on the the existing mappings or the schema structure of your data index, right? You can see that there is a mapping section with a properties. So properties are the field's definition as well as the behavior if you specify any. So you can see here, we just got a field called timestamp, and it's a date data type. We also have a response size, and then the type is a long. Now, the kinds of data types that we support are, of course, simple types and some hierarchical types. Now, simple types include strings. Now, strings is also subdivided into 2 major categories, the text and keyword. So keyword is for apple-to-apple match, identical matches. And text, on the other hand, is talking about like the relevancies, that is how relevant these terms are comparing with the actual document contents, right? And when we talk about dates, right, we have date and date in nanoseconds. So this thing depends. If you're talking about something like normal use case, the date in milliseconds is enough. But if you're talking about banking applications, which is like using those algorithm trace, maybe nanoseconds is more important to you. So that's why we have 2 types of dates. For integer types, we have also 6 types. We have the byte short, integer, and long. So they are actually just normal integers. But the difference is the range of the possible, the ranges of these data types are slightly different. So byte is 2 to the power 8. Okay, so 0 to 2 to the power 8, that is 0 to 255 values. So for short, it's actually 0 to 2 to the power 16 minus 1. And for integer, it's 2 to the power 32. Long is 2 to the power 64, etc. So let's talk about the range of the long integer that you can actually store inside this variable. All right. So that's why they actually represent the same thing, but just the range is different. Right. And the bigger the range, of course, the more memory you're going to use as well. Floating point numbers are pretty much like the Java thing where float and double. We also have something called half float, which is 2 to the power 16 instead of 2 to the power 32 or 64, right? We also have something called scale float. So we'll talk about what is scale float a bit later in this lesson, right? We also have normal Booleans like true and false. We also have IP addresses. So when we talk about IP, there is version 4 and version 6. So version 4 is something like this. All right. So version 6 is something like this. Just randomly type something. Yeah, it's something like that, right? So it's IP version 6. That's longer, right? Yeah, again, it depends, right? For most cases, IP addresses, you can just use a normal keyword because you're doing identical matches. But there are cases that sometimes you want to do subnet mask level filter. So you're dealing with subnet mask filters, then you will need to have the IP data type. Also, if you're using the IP data type to translate into geographical information, for example, this IP means it came from Philippines or come from Thailand. If you want this kind of information, you also need the normal IP address field. All right. So that's why it depends on the use case. For most situations, we might just probably use a keyword. So hierarchical types is like objects. All right. Remember, we told you that for a normal JSON document, right? Keys can be a normal value like a string. It can also be pointing to another object. So if you're pointing to another object, this is what we call hierarchical types, simply. We also have some specialized types that only Elasticsearch has, like GeoPoint. Now, if you ever use something like some car booking or taxi booking or maybe motorcycle booking in your country, like for example, Gojek, you probably will be using GeoPoint because now you are at somewhere and you need to tell the driver to go to that place to fetch you. So you need to have a GeoPoint telling that driver that I'm here at the X and Y coordination. All right, so that's a GeoPoint. However, you can also provide multiple points to plot a shape. So this is what we call GeoShape. Now, take example. If we're talking about points of sales, right? You might have one point of sales at every city, but somehow, when we're looking at the whole country level, you might want to separate, like for example, Indonesia into different pieces. For example, Jakarta is one of them. All right, and maybe some other areas you want to subdivide them into another region. So if you have the concept of region, you will need to supply multiple geopoints. So multiple geopoints will become a shape on the map. So this shape is useful for you to get the value of the total number of sales within this area or outside of this area. All right. So simply, if you have this kind of use case, GeoShape will be useful to you. So other things like Percolator are also available, all right? But in this class, we will actually skip all these things. We'll be talking about the basic data types and use cases only, right? If you want to know more about like geolocation things and so on, you can actually take a look on some other online classes that we provide, right? So we have small classes just talking about how to run like GeoPoints, how to run Percolator, etc. So next question, if we know that schema is kind of like important to us, or maybe you want to set a schema for your data indices, how do you do so? So two syntaxes. The first one is when you create a brand new index from scratch, you can actually run put index name and then mappings and then the property definition there. So that's the first time when you create a data index, all right? Simply like creating a table. However, there are cases that sometimes you already have an existing index and you want to do some changes on that. For example, add a missing field. All right. So in that's the case, use a second syntax. Put index/mapping and then the corresponding properties that you want to add back to this existing index. Right. So again, these two syntaxes are very similar. And so it's kind of like confusing. So for me, even for me, I actually forgot a syntax. So every time when I need to do this kind of operation, I will look up for the official documents on the correct syntax. All right. So for me, I also forgot. So anyway, just let you know. Now, next question is, it seems a little bit strange because we didn't really define any mappings beforehand. So if you still remember, we can actually do something like this, right? Just typing something. So actually, you can directly run something like a post, your brand new index, and then some body, all right, some data bodies, and then you can actually create the missing my new index without any issues, right? Because by default, we told you that we guess the mappings for you and create the missing index. So something like this, if you push something like this body here, we will actually just create the missing index called my index. And based on the data you provide, we guess the data type for you. For example, username, comment, strings. So typically, we would just make it as a text field plus keyword combination. And for the ones called details created, it seems like a date. So we just simply create a date for you. And for visibilities and so on, it seems like a string again. So text and keyword. Finally, the employee seems to be just a Boolean. So we just give it as a Boolean type. So we just guess from what you give me. So this guess is good enough. I would say it's kind of like okay for most situations, but when you're going into production, you might not want this to happen. All right. The situation in why we said that most of the cases the guess is good is because the data type should be compatible. But the bad side is usually we'll give you the most flexible data type that matches the data. For example, like status code 404. We know that this is an integer, but to be honest, do we need to have long data type 2 to 64, something like that? But do we need to have this range of long integer to store something that is so small like 404? Probably no. So I guess the most optimal data type for this situation is only a short. All right, 2 to the power 16 minus 1. All right, because for this status code, I guess it's just HTTP. So 200 for something, 500 something, that's it. Nothing else bigger than 500 something. So that's why probably short data type is very good enough. So that's why sometimes when we guess, it's not the optimal. So on the other hand, if you provide something like a date, if it was in something like YY MMDD, we know it's a date. But if you give me something like this, all right, 0708 2019, we do not know this is a date because the format doesn't match YYY MMDD. So we just simply treat it as a string, all right? So be very careful. That's why we say when we guess the data type for you, it might not be optimal because based on your business logic, the data formats might be very different. And that's why strange things might happen, all right? Customize the mappings. Now, customization of mappings is also quite important sometimes. Like, for example, if we find that this status code should not be long, how can we do it? So the shortest way or the simplest way is you create the index beforehand with the correct data types. Like, for example, you put my logs, status code is short instead of long, and then you pump in the first document inside it. And now the data should be stored with the correct data type instead of using a long data type, right? So the same thing, you need to understand this is kind of like similar to database. You create table structures. So when you pump in the first data, they know what the data type should be instead of like letting us to guess the data type. Now, sometimes when we find that even though using float, in this case, it doesn't really kind of like optimal because you can see float is also 2 to the power 32 minus 1, all right? So that's why for storing something like 1.99, something like a price, that's too small. I mean, that's too big, not too small, all right? So we should use a better data type. So for this situation, we introduce you something called scale the float. Scale the floats, we are actually scaling up the value into a pure integer. For example, if your price is always reaching something like 1.xx, something like that, we can actually boost it up by 100 times. So that's why the scaling factor here is 100. So this 1xx now becomes exactly 1xx in normal integer value. All right, so that's why 1.99 after boosting up by 100 times becomes 199. So then why do we actually, do these optional things to make it increase to a null integer? The first thing is because integers are always the easiest way for computer machines to handle, all right, instead of floating point. So again, I'm not going back into the university classes like why integers are better than floating points, etc. But this is a common sense, all right? So pure integers are always better performed than floating point numbers. That's for sure. And so that's the reason why we make this floating point 1.99 to become a pure integer. And so when we save it and do handlings like comparisons or arithmetics later on, it's much more easier. All right. And so the next question is, how do you know the scaling factor is 100 instead of 1000? So this depends on your side. So you are the one that's going to get this data. You are the data keeper. You should know the nature of the data set itself. So should you extend it to 100 times or 1000 times? Depends on your knowledge on the data set. All right. So that is the idea here. You are the one who's going to be responsible for making the decision here instead of like I tell you it must be 1000. All right. So that's the point. So remember, we try to convert a floating point back into a pure integer so that we can store them in a much efficient way. And when we do calculations, also much easier. So that's the point why we are floating, scale the float. All right. If not, you can just go back and use the float data type. It's also okay. All right. But just kind of like not very optimal. Okay, pretty much one of the important questions. Can you change the mapping? Now, the answer is no. Okay. Now, think about it this way, because if you tell me that there is a field with a particular mapping, okay, and so that means existing documents all have been created with the correct data structure for that field. And suddenly you say, I want to change it. And so what really happens is you need to trash everything, rebuild the missing data structures. So this is not a good practice because when you crash everything and rebuild the data structures, it takes time. All right. So that's the reason why we do not let you do so. All right. Also, there is a kind of like a transition period. You might be changing 10% of the data from this data type to that data type, but the remaining 90% are still in progress. So they're still in another data type. So when you do a search or do some operations, what should we do? Simply ignore the 90% of the data. So that's another reason why we do not let you change the data types. All right. So be very careful. So, however, if you really want to change it, there is actually a reindex API. All right, which is actually doing the trash and rebuild process, but it will take you very long time. So that is the reason why we usually do not suggest people to change data types. All right. However, you can always add new fields if necessary. Adding a new field doesn't really change much on the existing data because the new field means a new set of data structures. So for existing data that doesn't have this field, they simply do not have that data structure, and that's it. And so that's why when you search, you cannot search this new field's value under existing data because there is no such data structures. So that's why it's okay to always add new fields. So again, like SQLs, right? Like tables. If you suddenly alter table and add a new column, it's always fine because you just have a new column with some empty values for existing data. All right. So that's why it's always okay. The same concept. And of course, eventually you might need to repopulate the missing values, but that's another story. All right. And we don't talk about that here. Instead, we talk about this kind of scenario in Engineering 2 instead. Okay, so this slide is the last piece of information for this lesson. What are types, right? So this is actually a very stupid thing. So when we talk about types, this is not data type, all right? So data type is talking about something like integer, date, float, etc. This is data type. And when we talk about this type here, we're talking about document type. Okay? So don't confuse. It's actually two things. Now, document type is kind of like a faulty design in the very early days of Elasticsearch. And so we have already deprecated for a couple of major versions. And we assume that in version 8, the next major version, will be totally removing something called document types. So that's why, just to let you know, we have this kind of thing as a legacy faulty design. and we'll be removing it totally in the coming future. All right. So that's it. So anyway, just good for you to know, right? But I guess most of the people here are not using very old versions of Elastic. So pretty much you don't even heard of something called document type anymore. All right. So that's why it's okay. Just kind of like let you know something happened beforehand. Now the summaries, mappings is just kind of like a data schema. So make sure that if you are kind of like want to have controls on your data indices, create the index mappings beforehand, right? Don't let us guess because the guess might not be optimal. So that's the most important thing. Now then, you cannot change the mapping of an existing field. The reason is because you already have data structures for existing documents. So if you want to change the data type, you're actually changing those existing data structures as well. This is not an easy job, so we don't want you to do so, all right? Even though we have reindex APIs, but that's another story. Okay, questions. Mapping are defined per index level. This is true. Okay, so if anything is wrong on your mappings, only that index is involved. The other index, no interference. Nothing happened to that. So this is actually a good kind of like good mechanism because if something shit happens, it's only that index. That's it. All right. It's not affecting the whole thing, anything else. Number two, what data type will be guessed by us if you provide like 300 long? All right. Because we want to play safe. We know that's an integer, but we do not know the range of this integer. So we give you long, the longest possible range, 2 to the 64 minus 1. All right. Now, number three, you can change a field's data type from integer to long because they seem to be compatible. No, even though they're compatible in a programming level, something like that, the data structures are still different. So they are not actually compatible at all. All right, we don't let you change data type, even though it's integer to long. No such thing. All right. So anyway, just let you know, data types cannot be changed after you create it. So that's pretty much for today. So we only got 7 minutes left. Good. So tomorrow we'll continue to lesson 2, talking about the 2 types of strings. All right. So I'll end today. And we'll continue tomorrow at the same time.